Hi, I'm Guang, 50 years old. In this lesson on limits calculation, we are taking a look at this example here, where we're given that limits x approaches to 0, square root 1 plus tangent x minus square root 1 plus sine x divided by e to the power of tangent x plus a times e to the power of sine x is equal to 1 over b. And we need to find the values of a and b. Okay, so this question here, we will be using 3 different methods to solve it. But for this lesson, we will be taking a look at method 1 first, alright? So, the first method to this question, we will be using rationalization and L'Hopital's rule. Right. So, rationalization and L'Hopital's rule. Let's take a look at how we can use it first. But of course, you would also have to know what kind of form your question is. So, let's take a look at it. Now, if we substitute 0 inside, in the numerator, you'll have 1 minus 1, which is a 0. And in the denominator, you're going to have e plus ae. That's interesting to say at the very least. Wait, no, it is just 1 plus a, sorry about that. Then afterwards, it is equal to 1 over b, right? So, for this part, since you have 0 over 1 plus a if you substitute it in, if 1 plus a is not equal to 0, then your final answer is just 0, where b becomes infinity, but that's probably not the case, right? So let's take a look at what happens after we use the process of rationalization. So, rationalization, we're going to have limit x approaches to 0. And since this is in kind of a minus b form, we can multiply a plus b on both numerator and denominator. We're going to have 1 plus tangent x minus 1 plus sine x. Right, so this is what it will look like in the numerator. And then you're going to have e to the power of tangent x plus a times e to the power of sine x in the denominator, multiplied by square root 1 plus tangent x plus square root 1 plus sine x. Alright, so this is what you will be seeing, and you would also realize that for one part of this entire fraction, you could actually solve it already, which is the square root 1 plus tangent x plus square root 1 plus sine x parts, alright? Since here it is multiplied onto the entire fraction, and you substitute x inside, you just get 2. So, you essentially have half, then limit. So here's x approaches to 0, then in the numerator, you will see tangent x minus sine x, then divided by e to the power of tangent x plus a e to the power of sine x. Right, so this is what you are going to have. Now, in this part, since this has to be a 0 over 0 form, which means in a denominator, you could pretty much tell what a is going to be. Since when you substitute 0 inside, you're going to have e to the power of 0, which is 1. So 1 plus a, which means from this step, a is actually equal to negative 1, alright? So a is equal to negative 1, but this is also where we use the L'Hopital's rule. So you're going to have half limit x approaches to 0, tangent becomes secant square x, sine becomes cosine x, then this is divided by secant square x multiplied by e to the power of tangent x then you have to subtract cosine x e to the power of sine x. Alright, so this is the form that you are seeing. Now, since we do have both secant and cosine, why not just multiply by cosine square on both numerator and denominator? So we're going to have half limit x approaches to 0, 1 minus cosine cube x divided by e to the power of tangent x minus cosine cube x times e to the power of sine x. Alright, so this is what you're going to see. Now once again, you can choose to substitute in your x value to realize that this is again still 0 over 0. But before we proceed with another round of L'Hopital's rule, let's take a look at what if we could take out some things. What do I mean by take out some things? So once again, here you'll be having your half limit x approaches to 0. So take out some things. You look at the numerator. You have a 1 minus cosine cube x. What if we just take out 1 minus cosine x? So what's inside will be 1 plus cosine x plus cosine square x. Why do we have to do this, you might wonder? Well, that's just because we can make this simpler. Well, not a whole lot simpler, but any little bit more simpler is still worth it, right? Since this is multiplied onto the fraction, and when you substitute x in, this is actually a 3, which will give you a 3 over 2 as the coefficient. Then limit x approaches to 0. In this, 1 minus cosine x divided by e to the power of tangent x minus cosine cube x e to the power of sine x. Alright, so now let's take a look at this part. Since it is once again a 0 over 0 form, we can use another round of L'Hopital's rule, where we're going to see 3 over 2 limit x approaches to 0, sine x divided by something. And this something is secant square x e to the power of tangent x, then minus 3 cosine square x, but then chain rule and you have another sine x, and this becomes a plus. Then here you have e to the power of sine x, and then you have to minus cosine to the power of 4x e to the power of sine x. Alright, so now that we have this part, what we can do is multiply both numerator and denominator by cosine square. So when we do that, what we'll have is 3 over 2 limit x approaches to 0. So we're going to see sine x cosine square x in the numerator, and this is divided by e to the power of tangent x. Then you have to add 3 cosine to the power of 4x sine x e to the power of sine x, and then minus cosine to the power of 6x e to the power of sine x. Alright, so this is what we are seeing here. And of course, if you realize it quick enough, cosine square x, when you substitute 0 in, that's a 1, which you don't need to write here anymore since it is multiplied on. Alright, so let's take a look at this again. What kind of form is this? You substitute x in, x is equal to 0, 0 over 1 plus 0 minus 1, so this is a 0 over 0 form. Well, once again, we will be able to use the L'Hopital's rule. So we're going to see 3 over 2, and then limit x approaches to 0. Sine becomes cosine x. Well, this denominator is going to be very complicated since you have secant square x e to the power of tangent x, and then you'll have to add 12 cosine cube x sine square x e to the power of sine x, and this plus becomes a minus. So minus 12 cosine cube x sine square x e to the power of sine x. And then differentiate with respect to sine, well, you're going to have plus 3 cosine to the power of 5x e to the power of sine x. And then you have to differentiate e to the power of sine x. We're going to have plus 3 cosine to the power of 5x sine x e to the power of sine x. Alright, so this is what we are going to see so far. Next part, we are going to have minus 6 cosine to the power of 5x sine x e to the power of sine x, and then minus becomes plus. Then you have to differentiate e to the power of sine x, so we're going to have minus cosine to the power of 7x e to the power of sine x. Right, so is this part correct? Should be. Alright, so let's take a look at what happens now when we substitute in x is equal to 0. So when you put in x is equal to 0, the numerator is a 1. So definitely there's some kind of change. And then the denominator is what you're going to determine next. So you're going to have 3 over 2 and then 1. So your first term, you have 1 and then minus 0. Since all those terms with sine x will actually be 0. So 1 minus 0 and then plus 3. Then plus 0 plus 0 minus 1. Right, so this is what we're going to see. Now, there should be some simple math, which will give you 12. And since we're given that this is 1 over b, which means, in all, our answer is a is equal to negative 1, b is equal to 2. Right, so this part here will be our final answer for this example here. So this is just method 1, which seems quite a bit complicated, combining both rationalization and L'Hopital's rule. But in fact, L'Hopital's rule, you have to use it 3 times. Alright, so let's recap where we use it. Use it once over here. We use it once here. And nearer to the final step, we use it once again. And it finally becomes a determinable form, which then we just substitute in x equals 0 and get the final answer. Right, so that's pretty much it for this lesson. I hope that you're clear of it so far. Alright, this is method 1, rationalization together with L'Hopital's rule. So I'll be ending this lesson here, and thank you for your watching.